Okay, gentlemen, good morning. Today is probably Friday, if you're watching this on Friday, or you are watching this on probably Monday, getting ready for school on Tuesday. Either way, hope Bio AP exam went well. Just to go over where we left off last time, we had talked about starting the discussion on coterminal angles and how that's really differing by 360 degrees, which we said was the same as 2 pi. And the whole idea, analogy I was going with is about how many laps around are you. So looking at this guy, the red angle is here. The green angle is at the same spot, having already done one lap, so to speak. So he's 390. The red guy's at 30. But if I were to ask you, where are you on your lap, the one that you're on, your current lap, where are you? You would both say, well, both of us are right here. The green already did a lap, I know, but where are you on your current lap? Well, we're both right here, and that's what coterminal angles are. Where are you right now on the lap that you are on right now? We talked about how negative means you're going clockwise from quadrant 4, 3, 2, 1, and positive is 1, 2, 3, 4. Right, so we're going to have a couple of those coming up. But we got to remember that negative is going backwards. And how do I remember that? Well, positive is starting in quadrant 1, 2, 3, 4. We have our little all students take calculus chart. Positive everything, positive only sine, positive only tan, positive only cosine. Okay, and as we know, sine and cosine repeat themselves every 2 pi, every single 2 pi. Then there's these patterns every 90, 180, 270, 360 about who's positive, who's negative, what are my values. We know we're going to memorize that table with 30, 60, 90. And then they repeat also, but this is the big thing, is the exact cycle, positive, negative values, bam, every 360. Okay, so just to kind of summarize what we wanted, again, we care about where you are on your current lap of the coordinate plane, regardless of how many laps you've done. So we're focusing on where are you right now, regardless of how many laps you've done. So here's our summary. If I'm positive in degrees or in radians, this is pi over 4, 45 degrees. I'm counterclockwise, quadrants 1 to 4. And if I'm negative in degrees, I'm going clockwise, quadrants 4, 3, 2, 1. So that's what the negative has to do with going the wrong way. This negative sign is telling us direction. Okay, looking back over here, if I'm more than 360 degrees, then I want to add or subtract 360 to find my value. And that goes back to this idea. I don't care how many laps you've done. I want to know, where are you on your lap? So if I have a number bigger than 360, break it down to get a smaller number so that I know where you are on your current lap. If I have 420 degrees, I would subtract 360 and tell me, got it, so you're at 60. I know what your value is. If you're at negative 420 degrees, I want to make it a smaller number. I'm going to add 360, right? So you're all just kind of mentally playing with this 360. I just want to break down my number so I know. I don't care what lap you're on. Where are you on your lap? So if you're negative 420, that's saying I'm going this way more than a lap. I don't care that you've done a lap. Where are you? If I'm this way, positive, more than 360, I don't care where you are. I don't care how many laps you've done. Where are you? I'm at the 60 mark. Okay. So there's our summary on that. So now if we look here. Oh, I already had that. My apologies. Okay. So now we're looking here. We want to next talk about what a reference angle is. A reference angle, which I call theta r, is the quickest route that gets us to the x-axis. The quickest route that gets us back to the x-axis. In other words, we are creating those right triangles. And those are the ones, and I'll zoom out so we can still see that. And those are the ones that we had in our picture that I kind of highlighted from the beginning. These right triangles. My base right here is along the x-axis. Here's my theta. Here's my right angle. Over here, my base is the x-axis again. Here's my theta. Here's my right angle. Over here, the base again is my x-axis. There's my theta. There's my right angle. And lastly, here's my here's my base. Here's my height. Right angle, theta. I call that the bow tie. So if I'm giving you degree amounts, this is our basis. We want to get to the x-axis. How many degrees am I from where I measure my angle that gets me back to my x-axis? Because then I can create one of these triangles. They're all based on the x-axis. So what do I mean? Well, let's see here. Okay, so here we go. I have a coordinate plane. 135 degrees, starting at my starting point. 90. And somewhere around there. I don't know exactly where, but I'm somewhere in that quadrant. I'm in quadrant 2. Okay, and this right here is 135. Is this more than 360? No. So you're not more than one lap in. You're on your first lap. Good. I'm positive, so I'm going the right way. I want to create a triangle that looks like one of these. In order to do that, I want to find my angle, not this one. Look how far away that is. What is this angle? What I'm looking for here is, what is this angle? What's my reference angle? My angle that gets me from the number I give you to the x-axis. And that number we have here is 45 degrees. And I got that from saying, well, that's a 135 degree angle. My x-axis is at 180. So how many more degrees would it take to get there? 45 degrees. And now I have my right triangle that I can use to find sine of 45, or what cosine of 45 would be. Sine is opposite, cosine is adjacent over hypotenuse. Or I could find my tangent of 45 degrees. And these we would have memorized. And actually, this is one you have for classwork, so I'm not going to do it all the way out. But you have sine, cosine, tangent, cosecant, secant, cotangent. And you would just give me those values based on this hidden 45 degree angle. And that's kind of what this whole game is. Not only do we have coterminal with how many laps are you, get rid of that. What lap are you on? Where are you on the lap you're on? I'm here. Okay. Make it so that I have an angle I know. Get me to the x-axis. Give me one of these 4 triangles. How much to here? 45. That's something I know. I'm never going to make it, right, at least for now, something you don't know. It'll be 45 or 30 or 60. Eventually we'll get to 90 and stuff like that. Okay, so that's the idea for us. Like I said, this is part of your homework, so I'll let you finish this for classwork or homework. Okay, negative 30 degrees. Here we go. Negative 30 degrees. So the negative tells me, well, first of all, do it in this color. First of all, negative. I'm going clockwise. I'm going the wrong way. At least it's only 30 degrees, but I'm going from quadrant 4. I'm starting in quadrant 4. 30 degrees. Well, how close am I? What's my angle that gets me back to the x-axis the fastest? I could keep going, but look how huge this angle is. This angle's massive. What's the quickest way to the x-axis? Well, just here. How much is that? Well, you told me it's negative 30. What does the negative mean? It's this whole game with what quadrant we're in. So let's start this one. I'll do this one by hand actually out. Sine of negative 30 degrees. Okay, so all it's saying is what quadrant you're in. Okay, so sine of negative 30. Well, for us, that's really the same thing as saying, well, what is sine of 30 degrees? Well, I don't know. Let's kind of draw our triangle here. Here's our triangle. You should have sine of 30 memorized, but in case you don't, we have our ratios. And this would be the side opposite the 30 is always 1. The side opposite the 60 is always radical 3. And here's my right angle. Okay, but I got 1/2 cosine of negative 30. Again, that's the same thing as cosine of 30, just telling me I'm in quadrant 4. Basically, I'm saying 330 positive degrees. If I were to really relist this, it's 330 degrees positive. Come on. Right? That's really the same thing. Cosine is radical 3 over 2. And tangent of 30, right? So of negative 30 is the same as tangent of, run out of room here, 30 degrees. And that is 1 over radical 3, which if we want it rationalized is radical 3 over 3. Okay, we talked about rationalizing yesterday. Opposite over height over adjacent, in our case for tangent, times by radical 3 on top and bottom, and that's what it is, and that's what you'll see with your quiz on. What your quiz will be on. Okay, but now, well, what's the deal? Why does it have to be negative 30 degrees? What is it telling me? Well, from our acronym, all students take calculus. What quadrant am I in here? 4. All students take calculus. What's the only thing that's positive in quadrant 4? C, cosine. Everything else will be negative. So this is a nice problem because 1, you're using your 30, 60, 90, which we need to have memorized. 2, we got to know reference angle. This one technically has itself. There is no reference angle because it's just saying negative 30, and the closest way to get back is to go back 30. And then what quadrant are you in tells me if you're positive or negative. And then there's these kind of coterminal angles that we can play with too. So nice problem, uses a lot of trig and a lot of outside knowledge. Okay, obviously you would find this for cosecant, secant, and cotangent, and you'd kind of do the rest of these, but to keep this, the gist of it we're starting to get, hopefully. Maybe, I'm not here. 240, okay, do this one as best we can. Here's my angle. 0, 90, 180, 240 somewhere over here. No idea where. I like to draw a little, bam, 240 degrees. Okay, am I more than 360? No. Good, so I'm on my first lap. Don't got to worry about coterminal right now. But what is my reference angle? What I'm asking here is, what is the shortest route to get back to the x-axis? Would it be from here, here? Is that how I get back? From here, here? That's kind of long. Or here, here. That's definitely shorter. Well, if I wanted to know what this angle were, that little reference angle right there, what is that? Well, if this is 240 and this is 180, well, what's this little guy? Well, that is 60 degrees. Now I have my triangle here. I'll do it dotted. Here's my little triangle. There's my theta. And now I can answer all of the questions I need. So now you can see that what we have here is essentially, like I said, your hidden 30, 60, 90. Sine will always be the same at 30, 60, 90. So I'm going to, in each quadrant, so there's 30, 60, 90 in quadrant 1, 2, 3, and 4, and then that cycle repeats every 360. I'll make sure you always get a 30, 60, 90 because those are the only values we know. 60 degrees is radical 3 over 2. Cosine of 240. Well, we just saw that 240 is all the way over here, which is the same. My reference angle is 60. Same. Sine is the same at 60 every single time. Right? So every 2 pi I repeat, but then every 90 I will re-hit the values I want. Okay, and that is 1/2. Cosine of 60 is 1/2. And then lastly, we have tangent of 240. And that is the same as tangent of 60. And that is radical 3 over 3. No, just radical 3. My apologies. Just radical 3. Okay, I'm in quadrant 3. All students take calculus. All students take calculus. Negative, negative. So the only one that's positive is tangent. So again, my reference angles are saying what is the shortest angle that gets me back to the x-axis, and I need that because sine repeats, like has a pattern up to 90. 0, 30, 45, 60, 90. And those are values that I will have memorized. Then I'm still positive, just in reverse order. Like a 60-degree angle, and then a 45-degree angle, and then a 30-degree angle, all positive. So I'm going backwards. Right? My values I'm going to have memorized, and I go backwards, decreasing back down to 0, and now I'm at negative values. So sine has this up and down pattern of being positive with certain values, then it goes downward, then it goes negative, and then it goes back upward. Right, so it repeats that every time. And then coterminal is saying if I do a couple laps around, I'm going to get all those patterns again. But they also happen every 90, but the signs vary based on what quadrant you're in. So it's the 360-degree repetition. And in that 360, there's quarters. 90, 180, 270, 360. And in those quarters are my values. 30, 60, 90, 45, 45, 90. Just some are positive for sine, for cosine, for tangent, and then there's like a repetition of that. So a lot of layers here. Try your best on the homework or the assignment. You have 4 of these, 1 in each quadrant, and there's some reference angles we're going to have to find. Okay, good luck, and I'll see you guys on Tuesday.